The most common unit of concentration in chemistry is molarity, and molarity is moles of solute over liters of solution. However, other units of concentration are used. Percent by mass is the mass of the solute over the total mass of solution times 100. You want to remember that solution is solute plus solvent, and your final units here is going to be the percent sign. Molality is moles of solute over kilograms of solvent, and your final units here is going to be the lowercase m. Mole fraction of a certain component A, for example, is going to equal to the moles of A over the sum of all of the moles of the components of that solution. So moles of A over moles of A plus moles of B, and if that solution had another component, it would be plus moles of C, and all of that would go in the denominator. The units for mole fraction, no units for this final answer. Let's take a look at an example. A solution of calcium chloride in water forms a mixture that is 33.5% calcium chloride by mass. If the total mass of the mixture is 175.8 grams, what masses of calcium chloride in water were used? I like to start off with my given information, so I'm going to break down my story problem and see what I have. They start off by giving me the mass percentage. And this is 33.5%. They also give me the total mass of the mixture, which means this is the mass of the solution, 175.8 grams. And they're asking for the mass of calcium chloride, which is the mass of the solute, and they're asking me for the mass of water, which is the mass of my solvent. All right, I have all of my given information, and since I have mass percentage, I'm going to go ahead and write down the formula for that. Mass percent is equal to the mass of the solute over the mass of the solution times 100. Since I have my mass percent, I'm going to go ahead and plug in some numbers. I don't have the mass of the solute, but I do have the mass of the solution. I'm going to divide by 100 on both sides. And now I can go ahead and solve for m. M is equal to 58.9 grams, and it's the mass of the solute, so I just really solved for the mass of the calcium chloride. Now I want to solve for the solvent, but I want to remember that the solution is equal to the solute plus the solvent. I have the mass of the solution, I have the mass of the solute, so now I can solve for solvent. So the solvent is 116.9 grams of water. So I was able to solve for calcium chloride and water just by realizing that the calcium chloride is my solute and water is my solvent. Let's take a look at another example. In this example, we're asked to calculate the molality of a solution formed by adding 8.4 grams of NH4Cl to 13.8 grams of water. So I want to try to come up with my given table. It's asking me to calculate the molality, so that's my question mark. And the solution is formed by adding ammonium chloride to water. So the mass of my solute is 8.4 grams of ammonium chloride. And this was added to water, so the mass of my solvent is 13.8 grams of water. Now, it's asking for the molality, so I'm going to go ahead and write down the formulas, just see where we are here. Molality is equal to the moles of solute over the kilograms of solvent. Now that I have that formula, I can go back to my given table and see what I need to adjust here. I have solute, great, but it's in grams, so I'm going to convert my grams of ammonium chloride to moles of ammonium chloride. If grams of ammonium chloride is on top, then I've got to go ahead and put grams of ammonium chloride on the bottom. And I can get that number from the periodic table. Units cancel out, and I get 0.157 moles of ammonium chloride. I also need my solvent to be in kilograms. So I'm going to go ahead and convert. I know that 1 kilogram of water is 10 to the third grams of water. So this is going to equal to 0.0138 kilograms of water. All right, I've got all my units. So now I'm going to start plugging into my formula. Molality equals moles of solute over kilograms of solvent. So my final answer for molality is 11.4 in lowercase m. Let's take a look at another example. In this example, we're asked to calculate the mole fraction of ethanol in a solution that contains 46 grams of ethanol and 64 grams of methanol. All right, so we're going to start off, as always, with our given table. So given, I need to figure out the mole fraction of ethanol. So that's going to be my question mark. And they've given me the mass of ethanol, and they've given me the mass of methanol. Okay, that's all that they've given me. And they're asking for mole fraction, mole meaning I've got to have my units in mole. So I'm going to start converting right off the bat here. So 46 grams of ethanol on top, grams of ethanol on the bottom, and I can get that from the periodic table, is equal to 1 mole of ethanol. And my methanol, if grams of methanol is on top, I need grams of methanol on the bottom. I can get this from the periodic table, and this equals to 1 mole of methanol. Okay, I got all my units in the correct units. Now let's go ahead and solve for the mole fraction of ethanol. This is going to equal to the moles of ethanol over the sum of all the mole components of that solution. So moles of ethanol plus moles of methanol. I'm going to plug in my numbers. And I'm going to solve for that. And remember, final answer has no units. Good luck and keep practicing.